Okay, to draw the molecular orbital diagram for a diatomic of chlorine gas, we're going to need to know what the electron configuration is for chlorine gas. I'm just going to write the noble gas configuration for it. So we've got chlorine, neon, and then 3s2, 3p5. So what I have are 7 valence electrons, which we would expect because chlorine's a halogen. So this is in the 3rd energy level. So I've got 3, and then dun. So this is 3s, 3p, 3s, 3p. So 2 electrons here. And then up, down, down. Up, down, down. Okay, so these are not the molecular diagrams, but the atomic orbitals. And so now I want to put them together to make the molecular orbital. So we have what this is sigma s and sigma s star. So bonding down here, anti-bonding here. And then there are 3 bonding orbitals and 3 anti-bonding orbitals. So I'm going to take these electrons and I'm going to put this one right here. 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 Oops. Drew that guy upside down. Okay. So I'm going to take one of each. So let's say those guys go here and here, and then the next 2, 1 from each, and then 1 from each, and then 1 from each, and then 1 from each. And so what I have to deal with are 2, 4, 6, 7, 2, 4, 6, 7, so 14 total electrons. I've got 2, 4, 6, 8, 10, 12, 14 total electrons. So this is my molecular orbital diagram for the chlorine diatomic. And will it exhibit any paramagnetic properties? And the answer is no. It doesn't, because there are no unpaired electrons. If I was talking about sulfur, I would end up with these electrons missing, and these would be unpaired electrons. But I don't have that situation. All of these orbitals are paired up. Bond order. So the bond order is the bonding electrons minus the anti-bonding electrons divided by 2. So my bonding electrons are 2, 4, 6, 8. 8 minus. And my anti-bonding are 2, 4, 6. 6 divided by 2 equals 1. So I would expect 1 bond between the 2 chlorines, and that's what we have. Dry molecule containing sp3 hybridized carbon. Okay, I'll draw so this is an ether, and since this carbon right here, and for that matter this carbon right here, are bonded to 4 different things, 4 different objects, then I'm going to need to have orbitals going in 4 different directions, and so I'm going to need this guy is going to be sp3 hybridized. So I'm going to do next one, and I'll do HCH. Actually, I'll do this. This is formic acid or methanoic acid, and if you were bitten by a fire ant, this is the chemical that they inject into you. Okay, so how is this sp2 hybridized carbon? It's because this carbon here is bonded to, or the only carbon, it's bonded to 3 different things. Just because it's bonded to the oxygen twice doesn't change the fact that it's bonded to only 3 separate atoms. And so this guy is sp3 hybridized. Where is the, what's happening with the other p orbital? So I've got sp2, so 3 orbitals are, and then I have a second segregate p orbital, and that's being used to form this double bond. Okay, and a molecule with 3, a carbon that's sp hybridized. Let's do so this carbon right here is bonded to only 2 things, this hydrogen and that carbon right there. So it's only sp hybridized. And that's it. So, I mean, the easiness of determining hybridization is just looking at how many different things the carbon's bonded to. This carbon's bonded to 4 things, this carbon's bonded to 3 things, this carbon's bonded to 2 things. So then this is a 1 here and a 1 here, a 1 here and a 2 here, and a 1 here and a 3 here. So that adds up to 4, that adds up to 3, and that adds up to 2 things that the carbon is connected to. And this last question here is describing this diagram. So what I see here are several different things. First off, this bond in the middle is a sigma bond. And then the other bonds that I have are pi bonds. Can't really see that. I'll put that in black too. Pi bond and another pi bond. So the purple pi bond, that's 1 bond. This and this is 1 pi bond. And then for the blue, this and the one on the back side that you can't really see is 1 bond. So what I have is the yellow is a sigma, and then the purple is a pi, and the blue is a pi. And so what I have is a single, and then a double, and then another double bond. And all this together is 3 or triple bond.